In the last section, we finished up our client deployment configuration file, and we're now ready to toss this thing off to kubectl and see it running on our local cluster. Now, before we do, I want to give you a very quick reminder. If you flip over to your terminal and do a kubectl get pods, you'll recall that we still have the original pod that we had created with our client pod.yaml configuration file. I think that would be really nice if we got rid of this pod or somehow deleted it before we sent out our deployment. That way that when we get our pods in the future, we will only see the one pod that was created by the deployment as opposed to the one pod from the deployment and this one pod from the original client pod configuration file we had created. So I want to figure out how we can delete this existing pod. Now, to remove an existing object, we're going to be making use of the configuration file that was used to create it. So in order to remove an existing object, we're going to run kubectl delete -f, and it will pass in the config file that was used to create that object. When we pass in that configuration file, kubectl is going to look at the file. So here's the client pod file. It's going to look at this file. It's going to look at the kind property right here and the name specified as well. kubectl is then going to try to find an object with the same type that has the same name. And when it finds it, it's going to delete it. Now, one thing I want to mention very quickly here is that this delete command seems an awful lot like an imperative update to our cluster. And in fact, it really is. This is an imperative update. We are issuing a very direct command that says, hey, Kubernetes, I want you to make this very discrete change to the state of our cluster. Now, unfortunately, this is something that we really just can't quite get over. When we want to create a resource or change an existing resource, we pass in an updated configuration file. And so we're kind of leaving it up to Kubernetes to make the appropriate changes. But when we want to delete a resource, unfortunately, if we wanted to delete some object inside of our cluster, we would have to kind of take the entire state of our entire cluster and then subtract out that one object. In other words, it's just kind of hard to picture a way to make a declarative update that will delete an existing object. And so this is going to be the one kind of location where we kind of fall back to the idea of an imperative update to the state of our cluster. Okay, let's give this a shot. So back at my command line, I'll do kubectl delete -f, and then I'll specify the client-pod.yaml file. And then we'll see that the pod with the name of client pod was deleted. Now, if it appears that this command just seems to hang, it will eventually resolve after about 10 seconds or so. When the pod gets deleted, it's going through the same process in the background that usually gets applied to deleting a container with the Docker CLI. Remember, when you delete a container, or stop a container, I should say, the container is given 10 seconds to resolve, and then eventually it just gets killed. That's what happens in the Docker world. And the same thing is what happens when we delete a running pod. It gets 10 seconds to resolve and eventually turn itself off, and then after those 10 seconds, the thing automatically just gets axed entirely. If we now do a kubectl get pods, we'll see that we no longer have any running pods. Okay, so now that we've cleaned things up a little bit, let's try applying our configuration file of client-deployment.yaml to our cluster. After we apply this thing, we should see a new single running pod using the multi-client image. So I'm going to flip over to my terminal, and I'll do a kubectl apply -f client-deployment.yaml. And then we very quickly see that the deployment was created. So we can now print out the status of all of our pods with kubectl get pods, and we'll see that there is exactly one pod running right now. And it has a randomly generated name, very clearly tied to the client deployment that we just created. We can also print out the status of that deployment itself using the command kubectl get deployments. So we're still using the get command, the same one we were using before, but we're changing the type of object that we are looking for. So now, as opposed to looking for pods, we're looking for deployments. So I'll run that, and we'll see that we have one deployment called client deployment. You'll also notice a couple of interesting columns on here. We have ones across the board for desired, current, up-to-date, and available. Desired is a reference to the number of replicas or the number of pods that this deployment wants to eventually have. So at present, inside of our configuration file, we said that we want exactly one replica running, and so we have desired of 1. We then see current, so that's the number of pods that are up and running. We have up to date, which is also 1. So at any point in time that you make a configuration change to your deployment, specifically a configuration change to the template down here, the deployment would automatically mark all the existing pods as being out of date. And so we might see up to date go down to 0. And then as the existing pods get updated or recreated with that new configuration state, they'll eventually restore this up to date field. And then finally, available right here is the number of pods controlled by this deployment that are ready and available to accept incoming client traffic, or essentially just successfully running their containers with the appropriate configuration for each one. Okay, so that's it. So we've now seen how we can use a deployment to create a set of pods, or in this case, just one single pod. Now, the last thing I want to do is still make sure that we are able to visit our running application inside of the browser. So we want to make sure that this pod right here is in fact successfully running the multi-client image. And I want to make sure that we can still access our React project files. So let's take a quick pause right here. We'll come back to the next section and we'll make sure that we can still access this pod or this container in our browser in the next section.